All right, hello, fellow coder. Welcome to this next, hopefully very exciting lesson inside of our FreshVotes series. In this one, we had decided in the previous video that we were going to create a recursive algorithm. So, yeah, this is going to be fun. So, a recursive algorithm essentially has, I think it's three aspects that need to happen. One, a starting point. Two, a way for it to call itself, to be recursive. And three, it needs to be able to have a termination point. So we need to be able to start somewhere, make progress as we iterate through towards an actual end point. Okay, so I believe those are more or less, from a high level, the three things that a recursive algorithm needs to do, or needs to have. So essentially, this get comments without duplicates can be the recursive method that we have call itself. So we need to be able to iterate through something. So basically what I want to do is I want to change this so that we're not passing in a feature. Essentially what we're iterating through and iterating towards is we're iterating through a list of comments, which has a list of comments, which has a list of comments, right? So essentially the list of comments is what we need to be iterating through. So instead of passing in a feature to this method, if this is going to be our recursive method that calls itself, is we want to pass in a list of comments, right? Which means we're gonna break things because we're passing in a feature right now. So essentially we want to pass in feature.get comments. Okay, so that's sort of what we want to pass in there, and then we want to import. I guess the list is not imported, and it should return a list of comments, right? Does get comments return? Oh, it returns a set. Sorry, I guess we can have a set of comments, and it returns a set of comments. There we go. That'll make things happy. Okay, so there we go. That's the starting point. The second point, the starting point is here, right? That's where we start. The iteration point is it needs to call itself, so we need to call itself with something, right? So we will essentially, what we're going to do is we're going to say, if the comments dot get, we're going to iterate through each of the comments. So we're going to say, let's say comments dot stream for each comment. We will say comment dot get comments with an S, and we're going to call. We're going to call get comments without duplicates, and that get comments without duplicates will take as a parameter, oh geez, what's happening here? Comment.get comments, okay? And let's make sure that what's the problem? It's taking a list. So get comments here is a list. Okay, so we need to, let's first change this comment, get comments here to a set. Oh, I see we have an array list of comments. That could have been why we were... Oh, geez. Is that why we were running into the problem we were having before? Call this a tree set of comments. Oh, that might have been the root of the cause of the issue of why we had duplicates in the first place. But let's modify this code to have a set of comments. And let's not use this recursive. I just hit save, so now it needs to build. Let's temporarily get rid of the recursiveness of this method and have it just say, return comments. Okay, it's really going to do nothing more than return what we already passed in with get comments. But just for the sake of argument, or the sake of being complete here, let's go and check and see if changing the internal get comments within a comment object, see if it actually fixes the bug of having the duplicates. You never know, right? Let's just go in there and see what we see. Okay, cool. So we still have the same problem. We still have the test comment 5 as being a duplicate, so fair enough. The problem still exists, so we can still move forward with our solution here for our recursive solution, our recursive algorithm. So we have a starting point, which is here. We have a point of iteration, a point of recursion, which is right here. It's called this get comments without duplicates is calling itself. Okay, so I don't remember where I was. We were talking about iterating through, and we got to this point. So we're passing in. We're going through each of the comments and recursively passing in more comments, but that is not good because we need a termination point, right? Because otherwise it's just going to be going in and going in and going in. So the termination point, let me put some brackets around here so that we can have this be more structured, like so. Essentially, we need a way to, well, I guess it will automatically, it can only go through so many comments with the for each. So technically, it might work. Although we're going to say return comments here, which is going to return the same thing. So that's not good, right? So then that will be never ending, right? If we just keep on returning comments, it'll just keep going through the same comments over and over. So this is not good. This will be recursive forever. So instead, what we want to do, we want to return the... Oh, but we can't do that inside of a for each loop like this. Right. Okay, so we can't stream. Let's turn this into a regular for loop. So comment in comments. Yeah. Like this. Like so. And let me get rid of that return here. And essentially, I think we'll need to eventually return null or return an empty hash set or something like that. I guess, is it a hash set or tree set? I guess it's a tree set that it wants. So we will return a recursive call where we pass in the nested comments of this one, right? And it keeps going in and passing in the nested comments. And I'm trying to think, will this eventually terminate? Well, yes, it will, right? So we're going to go through each of the comments. We're going to return, which is going to go back in here with a list of comments, and it's going to iterate through that list of comments and return. And eventually, I guess I could say if, well, no, because if comments is empty, I was gonna say, if the comments is empty, I was gonna write an if statement here to say if the comments is empty, then return a new tree set that's empty. But that's already gonna happen naturally in the for loop, right? The for loop will naturally not iterate through it, and then it will skip over and say return new tree set. So cool. So this should, this is essentially, as it stands, is going to be hopefully going to be a recursive call with a termination point and everything, and it's going to iterate through everything, whatever. But it's not going to accomplish anything, right? We're going to recursively iterate through everything and return every comment and blah, 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 blah. But nothing, there's going to be no real work done here. We're just sort of iterating through everything for no reason. What we want to do is, while we are iterating, we want to keep track of the comments that we've already visited. So essentially, we also need to have a set of, we'll call it set of long, which is visited comments. Okay? And again, the same thing here, we're going to have to start with a new, we'll call it a hash set, because this one we don't need to maintain order. Is that how we do it? New hash set? Yeah. So we'll pass in, the starting point is going to be an empty hash set, right? And then you can see here it's complaining because we've added this visited comments here, but we're not passing it in here. So what we're going to do is we're going to, for every iteration that we do, we're going to say, hey, for the visited comments, we're going to add a new comment, .getID, right? Because we're adding a new comment. Now there's a property of the set such that the add method returns a Boolean. So what does that mean? It returns a Boolean. Why does it return true or false? It will return true if it was successfully able to add what you asked it to add. So if it successfully added this ID to this set of visited comments, it returns true. Well, okay, fine. What does it mean that if it's not successful? If it returns false, what does that mean? That means that it tried to insert a value, in this case an ID, but that value already exists inside of the list. In other words, we've already visited this comment, right? So we care about the return value. We care about it returning false. So if it returns false, if it returns, from the add method, when we call the add method, if the add method is false, in other words, if it's not true, then we are in a situation where we have a duplicate. We've hit a duplicate. We've already added this. So what should we do in the case that we already visited this guy? Well, I want to remove it from my set of comments. So in other words, I want to say comments dot remove this comment that we're currently visiting, right? Because this comment ID already exists inside of comments, right? And then we can pass in our visited comment list. But also, we also need to say visited comments, or no, we just did it. We need to remember to add to the visited comments. But this add method, because, you know what, let me do this. Let me take this guy and extract it as an actual variable. Add to visited comments. Added to visited comments. So we're going to assign it to a Boolean. That way we extract, sometimes it's hard to visualize everything that's going on. If a function happens inside of an if statement, it's a bit confusing. So boom, visited comments.add is the function where we are actually adding to our visited comments list or set. And then we have a Boolean value from that, which then we check to see if it worked or not. And then we pass back in to our recursive call the visited comments. Okay, so this is a funky method that we're working with. But hopefully, by the end of it, we will have removed, this is the magic right here, right? Everything around this, or everything around the if statement, everything around this comments.remove is just iterating through every single comment in the list, or in the set, right? That's all this is doing. But the magic happens, the magic is where we remove comments from the set of comments. We are removing the duplicates, okay? So by the end of this guy right here, let me extract this guy as a set. Oops, did I hit? Okay, we're good. By the end of this set that we add to the comments, to the model, hopefully should have removed the duplicates. So let me see what happens. First, let me just wing it and say run it without even debugging inside of the actual recursive method. So I'm just going to shoot from the hip and assume that my code's going to work, which is never a good thing to assume. So let me see. Refresh, log in, cross your fingers that we don't get some sort of weird exception. Oh, it's taking a while. Oh no, I hit my breakpoint. Okay, so comments without duplicates. Oh, it's empty. So who knows why it's empty. That clearly did not work the way we intended it, because now there's no comments. So how do we fix that? Well, we put a breakpoint inside of our get comments without duplicates method, recursive method. So let's get in there and see what we have. So visited comments is empty for the first time we're calling. Fantastic. Our set of comments should not be empty, which is the 1, 2, 3, 4, 5 comments. Fantastic. So then we will iterate through. So for the first comment, we will add it to the list of visited comments, which now we have visited comment number 1. Fantastic. We were able to add it. Now we take the visited comments and we pass in the comment.getComments. So comment.getComments in this particular scenario is going to pass in the nested comments within comment number 1. So again, we're going to hit go, and it's going to hit the breakpoint because it's calling itself. So now the visited comments should still be 1. But the set of comments should be different, right? We only have 2. Perfect. That's exactly what I expected. So comment ID 2 and comment ID 3, because those are the nested comments. So we go in, we add to visited comments. Now we'll see 2. Fantastic. And then we pass in the comments for number 2, right? Okay, I think I see what's happening here. We're returning new tree set, and that might be the problem. We should be returning comments, probably. Oh, but that won't have... Okay, well, let's keep going through and see what happens here. So now we're looking at... Yeah, that makes sense. So we were just looking at the nested comments for comment number 2, which doesn't have anything, and it returns a new tree set. So I think this is why, right? We're returning a new tree set instead of... So really... You know what's interesting here? Probably the end result is that feature.getComments is what is modified. That's my guess. Let me just take a stab at it and say play. We know that comments without duplicates is going to be empty, but I bet you, well, I don't bet, but I think that feature.getComments has been modified, potentially. Doesn't look like it actually, because it has all 5. Yeah, it still has all 5. I would have thought maybe that would have been modified, but yeah. So the problem here is in what I'm returning. I'm returning the new tree set, which is eventually just always returning back a blank tree set at the end of the day. So what we need to do here? I figured this was going to be a complex situation. Because at the end of the day, what we want to return is the final set of comments. This final set of like root level comments without the duplicates in it. Because we are removing... I almost want to do... Oh no, we are passing in comments. So we do have a reference to comments. Yeah, what if I say return comments? Because that's technically what we're modifying, and the modified version of comments is what we want to be returning, I think. I don't know. Recursive algorithms, guys, tough. They're tough on the brain. I'm physically dizzy right now just thinking about it. Although that could also be because I've been fasting and I'm hungry now. So anyway, we'll see what happens. So, yeah, it's still empty. Darn. So why is that empty? Okay. I was hoping to see more than nothing here. So let me go and run this again. Refresh. So why is this empty? So we are returning... We're passing in comments. This is number 2. Well, you know why? Because number 2, comments is still empty. Yeah. So that's returning comments back to here, which is returning that empty comments list. Yeah, that's what's going on. And then it's not even iterating through everything. It's only... Okay, so let me think here. We don't want to return the empty comments list. So that's what's happening here is we are returning the empty comments list from the second comment. So I don't want to return here. I want to visit it. Right? Only visit it if comment.getComments is not empty. So if comment.getComments, well, I could just say is not empty. Then we visit, right? Because if it is empty, then we don't want to visit it, because then we're going to end up returning an empty list, which is a problem. Now, anyway, we'll see where this goes. Let's see. Okay. Recursive algorithms. Again, hard on the brain. So we're going in. Boom. This is comment number 1, I guess. Right. Which has comments, so it's not empty, so it will call the next one. Cool. We're going in. This is comment number 2. Comment number 2 doesn't have any comments. So it will skip this and go to the next one, which is comment number 3, which does have comments, right? Yeah, comment number 3 has comment. Well, at least it should. Yes. So then it goes in. Cool. So now we're in comment, 5? Yes. So comment 5, here's the magic, right? We just added that to our set. So if we look at our visited comments, we visited 1, 2, 3, 5. So now 5 is in the list, and that's where the magic starts to happen. Cool. Now, comment number 5 doesn't have any nested, so it will skip over that, and it will return comments, which is itself. So it's returning 5. Back now, so now we're going back a page to, where were we? We were visiting from 3. So comment 3 is where we are. So we've gone back a page and we're in comment number 3, which comment number 3 has 2 and 3. So we're returning 2 and 3. So now we go back a page to comment number 1. So now we're on comment number 1, which has, oh, right. Sorry, this is the root. So there's comment number 1 on the root and comment number 4 on the root. So now we're visiting number 4, I think. No, number 2 is on the root. But I think we've already visited 2. So since we've already visited 2, that's going to be false, right? It returns false because it can't add it. And since we've already visited it, it's going to remove it from here. Boom. So now comments, yeah, it has 4 instead of 5. And then does 2 have it? No, we go to, what was the exception? Oh, concurrent modification. Shoot, right. I should have thought of that. So, yeah, you can't, oh, that's annoying. So I had a for loop, and I was iterating through a collection, which is a set of comments, and I modified that collection while I was iterating over it, and you cannot do that. So in order to do that, in order to be able to modify a collection while you are iterating through it, you need to use an actual iterator. So you can't use a for each loop. You need to say comments.iterator and assign that to a value. So call that ITR is usually what I do. And then it's not a for loop, it's a while loop. While itr.hasNext, right? Comment equals itr.next. Cool. And then what we do here is we don't say comments.remove, we say iterator.remove, I believe. Or iterator.remove? Oh. Remove whatever one we're on. Is that how you do it? Yeah, because if this comment we've already visited, we want to remove it. Yes, I think that's how we do it. So let's go back, restart the application. Oh my god, 23 minutes in, ladies and gentlemen. Again, I figured this was going to happen. Let me refresh. Okay. Let's see if this works. First comment. Boom. Add it to the list. Does this comment have children? Yes, it does. Go in. And we are going to look at the first child, which is number 2. Cool. Does 2 have children? It doesn't? No, number 3 has children. Number 3, add it. Does it have children? Yes. Go in, visit the children. The child is 5. Cool. Add it. So we have visited 1, 2, 3, 5. Does 5 have children? No. Exit, return itself 5. Cool. Now we're back at 3. 3, we're done. Is there another one? No, there isn't. So return 2 and 3. Back to the page 1, I guess. I think. Are we on page 1? Which is then 2. 2, false, right? We couldn't add 2. So we will remove 2 with the iterator.remove. Okay. How do I see if that worked? Comment.getComments. Is that right? What am I on? Comment. That looks like it removed too many, doesn't it? I'm not sure. We're going to have to see. Yeah, at this point my brain's fried, so I'm just going to say play through and see what it returns. Okay, that actually looks promising. Returned 1 and hopefully 4. Yes, that's correct. That's what we wanted to return because 1 and 4 are the root. Okay, and then 1 should have, yes, 2 and 3. Fantastic. 2 should have nothing. It doesn't. 3 should have 5. Darn. Ugh, so close. 3 doesn't have 5. So close. And then we go back to the model. Ugh. So our removal algorithm, I think it's because when it returns comments. Oh, so close. Okay. I'm going to refresh, go through this again. Comment number 1, cool. Add it, go in. Comment 2 is there, doesn't have any children. Comment number 3 does have children. Go in. 3 should have 5. 5 is there. Boom. So we return 5, like so. Back to here. So now, what does this have? This has 2 and 3. Okay. So now we're back. That was 2. I don't know where we are. Are we on 3 now? So now we're back at the root. This comment is 2. So here's the thing, right? This is where we are removing 2 from the root, which makes sense, right? Because we've already visited 2. Fair. That's fair. We should remove 2 from the root. Totally okay with that. And then 3, we should also remove from the root. Totally okay with that. And now we have just gone into another one. So now we're looking at 5 on its own. Why are we looking at 5 on its own? Because we must have gone in and I missed it. So in here, this is helpful for debugging recursive calls. We can go back one page to see what was in here that we passed in, right? So we were looking at comment 3. Right, because 3 was on the root, right? And we sent in comment.get comments, which was 5. Okay. And we are here with 5, and 5 we've already visited, right? We visited 1, 2, 3, 5. So again, we should remove 5 from there as well. And this one won't have anything, so now we've gone... We're returning nothing, so we're going back a page when we were visiting 5 or 3 as on the root, I think. Comments. Yeah, so now we're back on the root. So 1 has 2, 3. 2 has nothing, shouldn't have anything. 3, so this is where, if this doesn't have anything, yeah, this doesn't have anything. So we've already hit the problem, right? The problem has already happened. So why is it removing... When we say iterator.remove, I wonder if that's removing all the comments from everything. Oh, ladies and gentlemen, this is hurting my brain. So refresh. Let's pay attention to when we get into 1, and then we get into 3, and then what we do with 3 inside of 1. So we're on 1, get comment 1, go into the children of 1. Now we're in the children of 1. The children of 1 has 2. And we're going to go into the children of 2, which doesn't have anything. So now we go to the next iterator, which is 3. So we're in the children of 1. We're on 3. 3 has children. So now we're on going into the children of 1, 3. So now we're on children of 1 and 3, or the child of 1 and 3, which is 5. So we're looking at 5 from the children of 1 and 3. And we return it. Return 5. Back to, so we were at 1, 3. So now we're on 3. And 3 shouldn't have anything next, right? So that's good. That's correct. It should be returning 2 and 3 should still have 5. It does. Cool. So now we're on 3 going back to 1. So now we're on 1. We're going to go to 2. Right? Because it's 2 is the next one inside of the root. Yes. So now we're in 2. So now we've already visited 2. So we're removing it. So what happens when we do that? What just happened? So 2 is gone, but 1 still has... So 2 and 3 are still there. Fantastic. 3 still has 5. Fantastic. Okay. So now we're done with 2. So now we can go to 3, right? Because in the root, we have 1, 2, 3, and 4 in the root. So now we're visiting 3 from the root. We've already visited 3. So we're going to remove it. So now what does that look like from comments? So 3 has been removed from the root. What about inside of 1? 1 still has 2 and 3. 2 and 3. 3 has 5, so we're still good. So now we would just remove 3 from the root. 3 on the root has 5, right? Interesting. 3 has 5, but we've already removed 3 from the root. When we remove something, should we visit its children? If we are removing itself, if we've removed it, should we try to visit its children? Probably not. That might be where the bug is, because now we're revisiting 5. Okay, so now we're revisiting 5 from 3 that was on the root, so we're on 5, and we're saying remove. So before I say remove, I haven't hit remove yet. I guess I have to hit remove. Now it's gone from comments. And there isn't any children. So now we are back to the root. Right? And I think we're at the root. Are we? No. We were on 3. Now we're at the root, I think. Yes. So now does 1 have 2 and 3? Yes, it does. Does 3 here have 5? No, it doesn't. So I think that's where the bug is. I think if we remove from the root, we should return comments? Maybe. I don't know, man. At this point, I'm getting into the trial and error stage and not using my brain. So let's refresh, or reboot and refresh. Log in. I'm just going to Hail Mary it and say go, or get rid of the breakpoint and say go, and see if comments... Yeah, so now this looks a little strange, right? We have 1, 3, 4, and 5, so it only got rid of 2. And 1 has 2, 3, and 3 has 5, but we also have 5 on the root, so that's probably not going to work. No. If we remove... So we removed 2 here, right? We've removed 2 from the root, which we saw, but then it returned comments too soon, I guess. Oh boy, I don't know. This is a... How long are we now? 33 minutes in. Yeah. Recursive algorithms. So now we're at 1, passing in... Where are we? 2. Because 1 has 2 and 3. 2 doesn't have any children. Here's 3. 3 does have children, so we're going into the children. So it's 5. 5 is here. Add it to the list. Go back to return 5. Then we're on 3. Is there another child here? No, there isn't. So we return 2, 3. And then we're back on the root 1. 1 has another next, which is 2. 2 we have already added, so we remove 2 from the list, and then we're returning. Yeah, so that's why we end up with this list of 4. So I'm trying to think of what makes sense here. I'm trying to say, instead of saying return comments here, should we return comments only in a specific scenario is what I'm thinking. So if you look at... So what are we on? Yeah, see, we're just on... We have no children. So, I mean, to me, this is okay. To me, I feel like that is the correct thing to do, is return comments. Oh, but then we exit completely. Because what we did was we returned comments. We returned from the root. We were on the root. We were on the root, and we returned comments, which essentially means we're done, right? When we return when we're on the first page. So recursive algorithms are all about pages. When you first go in, the first visit you make is page 1. So if we're on page 1, and we say return, that's it. We're returning. We're done the recursive algorithm. If we're on page 2 and we say return, we're going and returning back to page 1, which means we're not done, and we keep going. And if we're on page 1 and we return, then we're done, right? If we're on page 3 and we return, we go back to page 2. If we return, we go back to page 1. If we return, we're done. So what happened was we returned too soon. We returned, we were on page 1, and we returned, and therefore we're done. But we weren't done. We still needed to iterate. So essentially the scenario that I was potentially saying that we need to return from is if we're deeper down the pages in the recursive method, and we're removing a duplicate. So, how do we figure that out? It's almost like we have to have a counter or something, int or int page, right? So we can see what page we're on. And we start at page 1, right? And when we go here, we return, ++ page, which essentially what that will do is it'll increment the page that we're on and pass that in to, the method. And I can say if page is not equal to 1, then return comments. Maybe. So let's see if that does anything. Oh boy. We're getting pretty creative with our coding here, but hey, if it works, then this is just called a beautiful coding solution, right? It's going to be very difficult to debug later once I'm done. If I do finish this and we do get through this scenario, this problem, then this is going to be quite the interesting situation. Anyway, let's see. Get comment with duplicates. Boom. So now we're in page 2. Yep, page 2. So what are we doing? We are looking at, we're at the second level of nested, or second depth level, whatever you want to call it. 2 does not have any children, so we won't increment to page 3. Number 3 does have children, so we're going to increment that page and go into page 3 now. So we're page 3 in our current situation. Boom, we're adding comment 5. It worked. Does comment 5 have any children? No, it doesn't. So we're going to go back a page, and then we're back to page, or not page. We're back on page 2, are we on page? So why is that page 3? Does that make sense? Maybe. I thought it would have not changed the value. Yeah, there we go, page 2. Okay, so we were on page 3. Comment. No, but are we back at the root? We're back at the root. So the root shouldn't be page 2, right? The root should be page 1. Because here's the remove, and then we're going to hit this and say, hey, if page is not equal to 1, and then we're going to return comments, and that's going to fail. Shoot. So why did that not work the way I thought it was going to? Maybe I need to do it the other way, page ++. I would have thought, I guess maybe that is true. You want to increment it afterwards? Yeah, but that's... We'll see. We'll see. Okay. You can see how hard my brain is working. Okay. Hopefully you guys are getting a lot out of this. Hopefully it's very interesting. So are we still page 1 or page C? Yeah, it still says page 1, right? Even though we've gone into page 2. So I guess what we should do is we should maybe start with page equal to 0. And then the first thing we should do is when we get in, we do a page plus plus. And then we don't pass in page plus plus, we pass in page. Maybe that's a better way to do it. So that way we are actually incrementing the page that we're on right when we actually visit a new page. Yeah. I think that makes sense in my brain. Let's see. So if we're on page 1, good. Go through. Does 1 have children? Yes, it does. Pass page 1, but then we're going into page 2, so we're going to increment. So now we're on page 2. Yes, we are. So now page 2, we're on comment 2. Does comment 2 have children? No, it doesn't. Now we go to comment 3. Does comment 3 have children? Yes, it does. Pass in the page 3. Good. And we're on comment 5. Add comment 5 to the list. Does comment 5 have children? No, it doesn't. So we go back to page 2. Fantastic. That's what we want. We're on page 2. Do we have any more comments to iterate through? No, we don't. So we return all those and go back to page 1. Fantastic. Do we have any more comments? Yes, we do. We go to comment 2, but comment 2 is already on the list, so we don't add it. False. Good. So we remove 2, and if we're not on page 1, but we are on page 1, so we don't return comments. Ooh. So now we're on comment 2, right? Yes. Does comment 2 have children? No. Go to comment 3. Does comment... All right, we've already added comment 3, so we remove it. Are we on page 1? Yes, we are, so don't return just yet. Does comment 3 have children? Yes, it does. It has 5, so go in here. We're back to page, what, 2? On page 2, we have comment 5. Comment 5 is already in the list, so we remove it. Okay. You know what is the problem? Well, we'll see. Let's see if this works. I feel like this is not going to work, though. Because let's go to comments. So this looks better. We have the right situation here, but comments... Yeah, see, it did remove it. So it returned... Okay, here's what went through my mind. Essentially, I think what's happening is we are removing it. Is it that we're removing it twice? Are we removing it twice? Well, because we're returning it. We go page 1, page 3, page 5. Or sorry. Comment 1, comment 3, comment 5. Comment 5 returns it. Comment 5 comes back to page 2. Page 2 goes to comment 2. Cool, whatever. Well, not cool, whatever. It removes comment 2. So it's almost like we should say we removed comment 2 already, potentially. So then we're on page 2, or no, page 1 now, because comment 2 is on the root. We are removing page 2 from the root. Okay. We go to page 1, comment 3. Comment 3, we has children. Now, comment 3 we've already removed. No, we've already visited. We did 1, 3, 5. 3, 1. 2. Sorry, we don't remove 2 because we haven't. No, 2. Sorry, 1, 2, 3, 5 is how we visit. Right? Comment 1, comment 2, comment 3, comment 5. We go back. There's no more comments there. We go back to root. Root, we go to the next one, which is 2. The page 1, comment 2, we've already visited, so we remove it from the root. That's okay. See, that's what's interesting. When we do that, it doesn't remove comment 2 from the It doesn't remove comment 2, does it? From our list? If I just say go and visit, right? Comment 2 is still there. So the problem is arising when we get one more level down. Now, hold on. Let me get rid of my... let me go to feature. Let me get rid of my little if statement here, just in case it's a display issue. You know, I don't think it's a display issue, but hold on. No, it's not. Okay. So I just wanted to make sure that it wasn't just a display issue that was throwing me off. So how come comment 2 is still there, but comment 5 is the one that's getting messed up, right? So the mess up here is in the nested of a nested. So then when you have two levels of nesting, that's where we're running into a problem. So let's think about that. Oops. Why are we running into the problem when we have a double nesting situation? The single nesting situation, perfectly fine. We're not doing anything wrong. So why is it unique to the double nesting situation? And I'm going to have to call it soon because I'm getting real hungry. It's lunchtime for me, and this video is going way long. So, I mean, maybe this is a good point to stop at because we've kind of, you know, I've come to a realization that, hey, the single level of nesting works. The double level of nesting is where we're running into the problem. So yeah, 1 goes to 2, which doesn't have any children, which goes to 3, which has children. So we go in, page 3 has 5. 5 doesn't have any children. We go back out, return 5. We're on 3, doesn't have any more. Return 3, 2, 3, 5, right? 2, 3, which 3 has 5 in there. Oh, where are we right now? We're in 1. Right, which would go to 2. So 2 is already in the list, so we remove it. Which is okay. That doesn't break anything, right? It removes it from the root, but it does not remove it from here, right? So why? Why did that iterator remove statement not mess up the nested child inside of the root? Interesting, right? But this guy, comment 3 here, which has 5 in it, when we remove there, it affects the first comment. What's up with that, right? So we're on comment 2. Does 2 have children? No, it doesn't. We go to 3. 3's already been added. So here, we're looking at 3. We remove it. So we remove 3 from the root. Has that affected the nested? No, it hasn't, right? 3 still exists in the root. 5 still exists there. But then we go in here, right? It's almost like I want to say, well, I don't want to say return comments, but I kind of want to say don't visit here, because that's where we get into trouble, right? So it's almost like I want to say if added to visited comments is false. No, if it's true, in other words, if it's successfully added and we have children, then visit them. Right? That's kind of what I want to, kind of the situation that we're running into. If and only if we added successfully, then we should continue to visit. Okay? You know? Maybe that might fix the problem. And we don't want to return too soon. But I do feel like if this works for this situation, I still think that there might be other situations where it breaks, but I guess we can cross those bridges when we get to them. So that works. We go to the children of 1, which has 2. Children of 2 doesn't have children. 3 has children. Cool. We visit that. 3 has 5. Cool. Does 5 have children? No, it doesn't. We go back to, what is it, 3 we're on? 3, done here. We don't have any more. We go back to the root. Root has number 2. Cool, but we've already added 2, so we remove it there. We don't visit because it doesn't have children anyway. 3 is here. 3 we've already visited, so we remove it. And since it was false, we don't visit. Yeah, there you go. Okay, then we go to 4, right? 4, do we have this guy yet? No, we don't. So boom, we add it. Does 4 have children? No, it doesn't. 5. Does 5 have anything going on with it? Oh yeah, we've already visited. Yeah, we visited 5. This might remove it from. So at this point, comments is probably looking pretty darn good, right? We have 1, 4, 5 needs to be removed, but in here, this guy still has 5. Yeah, so right now everything's good, right? We're happy. We're about to remove 5 from the root. Please tell me this doesn't remove 5 from here. Please, please, please. 2, 3, please, please, please. Oh, it looks good. Oh my god. Oh my god. That looks good. Oh my god. Oh my god! Success! Oh, wow. Whew. Now, okay, so we'll call, there you go. I did it in under an hour. That's a long video. But I wouldn't celebrate too soon. The next step in the next video is going to be to add a lot of nested comments. Think of all the different ways we could break this algorithm. Shove in comments, nest them even more. Let's go like 3, 4, 5 levels deep of nesting and have all that stuff, right? So in the next video, we'll set up that test case. We'll rerun it through this algorithm and see if it works. My gut feeling is it won't, but if it doesn't work, we might still be, well, we should still be able to debug and find out where it's breaking and adjust our recursive algorithm accordingly. Hopefully it works out of the gate and we're beautiful. So, because this is a long video, thank you so much for sticking around. I had a lot of fun doing this, even though it was hurting my brain, and I'm very, very hungry. In any case, I look forward to seeing you in the next one. Thank you so much for sticking with it. As always, take care of yourself. Hope you learned a lot here. Happy learning, and bye for now.